So, what I'd like to do is continue our discussion of psychopharmacology. We talked a bit about routes of administration. We talked about drugs, what those do to you a little bit. We'll revisit that more in a later chapter. Then we started talking about specific neurotransmitters, right? And so today we're going to talk about dopamine, a few other things, try to knock this chapter out. Dopamine is part of this large group called the catecholamines, which all fall under another large group called the monoamines. That's not going to be terribly important to you, Sydney, until you start thinking about things like monoamine oxidase, right? And then you might want to think about, well, monoamine oxidase can really affect all of the monoamines, right? So then it becomes important. Otherwise, in terms of classifying these drugs or these chemicals, it's not that important. It's usually based on structure and synthesis pathways. So we've got dopamine. This is one of the major neurotransmitters that you have. It's involved in just about everything. Movement, it's involved in learning and memory, reward circuitry. If you do something and it makes you feel good, there's probably some dopamine release involved in that. That's why you repeat that, right? How many of you have done something that felt good? And then you tried to do it again, right? That's why, right? Because dopamine made that rewarding. If you did something and it didn't feel good, you didn't try to do it again, right? You tried to avoid that. There is L-Dopa, and I love the pronunciation guides they put on here, so I leave them because I think they're brilliant. Still my favorite of all time is the gonads. It's monads, which is just hilarious on many levels. So L-Dopa, don't worry about what the L means. That's related to the orientation of the molecule. Nothing that's going to be important to you. This DOPA is actually a precursor to dopamine, so you would use it to treat Parkinson's disease. If you give people more 2x4s, they can build more houses, right? So the idea is if we give you more DOPA, you can build more dopamine. Parkinson's disease is the loss of your dopaminergic cells in what we call the nigrostriatal pathway. There's the substantia nigra that projects to the striatum. Those dopaminergic cells die. That's what causes these movement problems, right? And so if you start giving people the precursor to dopamine, then they make more dopamine, right? The downside of this is something called schizophrenia.
Yeah.
Okay. Schizophrenia, we'll talk about later, is actually elevated dopamine levels, right? That's the sort of the primary hypothesis. There's the dopamine hypothesis of schizophrenia. If we continue to give you that precursor to dopamine over and over and over and over again, your dopamine levels will increase. They may increase to the point that you start hearing voices. And that's the point where we realized, hey, we've given you too much, right? And so you have to try a different approach. The flip side of that is if we treat you for schizophrenia, right, we're going to give you a dopamine antagonist, right? So we're going to want to try to knock down your dopamine levels. That's brilliant until we accidentally give you Parkinson's disease, right? And at that point we call it tardive dyskinesia. We'll talk more about this later, so you don't really need to know this. And that's a sort of a drug-induced movement disorder that is basically it's very close to Parkinson's disease in terms of its symptomology. The cause is going to be different. The cause is because we're trying to treat you for something else. You have a couple other groups, a couple of other neurotransmitters that are down here in the monoamine group, norepinephrine and epinephrine. Sometimes these are referred to as noradrenaline and adrenaline, right? How many of you have ever heard of adrenaline? No one? That's great. Adrenaline, why do they call it adrenaline? If you look at the middle here, you've got the word renal. It comes from your kidney. Some of you have kidneys. They're sort of shaped like that. On top of your kidney, you've got this small, I call it an elf hat, right? Yeah, it's the adrenal gland, right? And so that's going to make these guys, they come out. If you start to think about the things that happen when you're having an adrenaline rush, these are what are mediated by norepinephrine, right? They jack up that sympathetic division of your autonomic nervous system. Don't worry about that. We've already talked about dopamine. briefly. We talked about the nigrostriatal pathway, right? Movement disorders. The other two pathways, the mesolimbic and the mesocortical, these are going to be involved in reward circuitry, attention, learning, memory, things like that. Okay, that's where those guys are going to play a role. We will talk about those later when we talk about neurological disorders. We talk about particular systems that rely on that. We've already talked about Parkinson's disease, degeneration of that nigrostriatal pathway. This is a rat brain cut in half. There are sort of the two major areas that create dopamine, two major sources of dopaminergic neurons. You can see where these guys project sort of everywhere. The problem is if you have a reduction in dopamine synthesis in one pathway, we give you a systemic pill, systemic administration of a drug that's going to raise dopamine levels. It's not just going to increase dopamine levels here, it's also going to increase dopamine levels out in these other areas. Right? And this is the guy kind of in that frontal cortex area that's going to give you those schizophrenic-like symptoms. Okay. Don't worry about apomorphine. Oops, wrong direction. We should think briefly about monoamine oxidase. Adriana, this is when I told you it was important to know about monoamines, right? Otherwise it's not. Monoamine oxidase is a guy that will break down monoamines, particularly we'll think about dopamine here, doesn't really matter. Takes that dopamine, converts it into some inactive substance, right? Sometimes you will see drugs called MAOIs, right? You'll see warning labels. Yep, they're monoamine oxidase inhibitors. So they'll just stop. And there's one of those inhibitors. You'll block that process. When you block that process, you have more dopamine. Look how much more dopamine is jammed into that vesicle. What do you think, Sammy, happens when we dump this at the synapse? Flood of dopamine. You get more dopamine, right? So that's awesome. Assuming you need more dopamine, right? If you don't need more dopamine, that's a problem. Norepinephrine, a major place we want to think about here is the blue spot, the locus ceruleus. Okay. Again, it's going to activate that sympathetic division of the autonomic nervous system. There you go. I guess I should circle it in blue since that does mean the blue location. It's going to go down to the spinal cord, your cerebellum. You get other places involved. Think about the amygdala, the hippocampus, cortex. These are all the things that are going to be activating that autonomic nervous system, having that response, right? Hey, who's heard of serotonin? Right, like everybody, that's great. We typically abbreviate that 5-HT. Don't worry about what that stands for, just know it stands for serotonin. It's an abbreviation of the chemical name for that. Serotonin's involved in a bunch of stuff: mood, eating, sleep, arousal. We're thinking about that related to sleep, regulation of pain. So folks will take an SSRI, right? That's a fairly common drug we've talked about briefly. Blocks the reuptake of serotonin. It'll increase your serotonin levels. That's great if you're sort of aggressive, you're agitated, you're depressed, right? That's awesome. What it's not awesome for is making you sleepy, right? So I don't know if you've ever seen someone go to sleep aggressively. Doesn't happen. And that's because when you're sleepy, your serotonin levels are up, right? One of the major side effects of an SSRI is sleepiness. Here are the serotonergic pathways, sort of the main hubs there of serotonergic neurons. We're going to send this out to a lot of places: cortex, again, amygdala, basal ganglia, your thalamus, variety of places. Basically, it goes everywhere. Again, the problem becomes treating this systemically. So when you give someone an SSRI, because their serotonin levels are low in one particular place, it's going to raise serotonin levels there, but also in the other locations, right? So that's why you have those side effects. Histamine, you don't need to know much about that now. We'll talk more about histamine when we do sleep-wake kind of business, right? but if any of you have taken an antihistamine like Benadryl, you know, it typically makes people sleepy, right? Okay. There's a small subset of folks who take Benadryl and they get hyperactive, right? So I don't know if any of you fall into that category or not, but watch out for that if you're trying to like drug your kids, right? Because you want them to go to sleep. Whiskey is a much better option because that does work on everybody. So there you go. Always,
No side effects.
no side effects to giving your kids whiskey, I promise. You can even buy the cheap whiskey because they don't have an advanced palate. They don't know what's good, right? Right, Jacob? You agree, right? So, yeah, that's a plan. Right there. Because then you can like give your dog whiskey, and that's you know, I don't know. I think about that sometimes. Like, you never hear about people giving their dogs whiskey. They'll give them beer, but not whiskey. I guess it's more expensive, right? Anybody have horses? Sometimes they give horses beer to help their digestion, right? So it's a good excuse to drink, I guess, right? If you've got digestive problems. Typically like wheat beers. Guinness, and Guinness. I've heard Guinness is great for racehorses. I don't know. I think it's how much you give them, right? Because like if you just give them like a pint of Guinness and one of you's probably not going to increase your speed. But if you weighed like 1,000 pounds, I don't know that a pint of Guinness is going to make a real difference to you, right? Because it's dose, right? Just for body weight. Here's histamine. Don't worry about this too much. Again, we'll talk about it later. Here's a whole list of drugs you can read about if you want. We'll talk about them later in detail where we need to. I guess we should briefly talk also about peptides and lipids. These are similar to some of the other chemicals we've talked about, but they have slightly different structures. In the end, the result is going to be similar. They're still going to work as neurotransmitters or neuromodulators. A peptide is simply a few amino acids, right? We're not having a whole string, right? So if you have a full protein, you know, like dopamine, like a receptor or something, you're going to have, you know, maybe thousands of amino acids, right? It's going to be very long. Peptide is just going to be a short chain. One of the big peptides we want to think about are the endogenous opioids, right? You stump your toe, you're going to release opioids. You have those inside of you, Rosie, so that's awesome, right? Just go around stumping your toe. I wouldn't recommend that. But you do have opioids that are released. This is why synthetic opioids and even naturally occurring opioids work, because you have opioid receptors. In terms of lipids, what are some of the sort of lipid-based chemicals that work or compounds? Endocannabinoids, right? So you have endocannabinoids. You've got cannabinoid receptors. We'll talk about that again when we get sort of later in the semester. This is why when you take substances that can contain cannabinoids, that you actually have some sort of effect, right? Because you have receptors for that. So there you go. A lot of these are involved in like food intake, regulation of food intake. Not surprisingly. All right, here's some more drugs. We can talk about those if you need. Who has questions, comments, concerns?